So continuing on here, actual minus predicted. They gave us the residual. We don't know the actual. That's what we want. I'm going to just call it X, call it George, whatever you want to call it. And then our predicted amount is 1.49. So solving for X, one-step equation, we're adding 1.49 to both sides, and we would get 2.117. Okay? So this is a good question because it really makes you have to understand what all the pieces are. Actual is always going to be your table of values. That is actual. Predicted or model is what we get in our calculator. That table of values in our calculator is not going to match this exactly. It's going to be close. The difference between those values is your residual. You graph a whole bunch of residuals, you want no pattern. Trying to make all those connections, okay? All right, and our last question, just a side note, 87, the key on Canvas, my 87 is completely different than your 87. I don't know why. That happened on another problem too. So, but this is a great question because we had two of these in the non-calculator portion where we had to find the intersection, the X values of the intersection. We set them equal to each other to do it algebraically. Here we're going to use our calculator because it's weird decimals. It's not unit circle angles, okay? So I'm going to clear my RAM and I'm going to type them both into y equals. Now the first equation, pretty simple to type in. And the second equation is also easy to type in, but I don't remember showing it to you guys. Every class period, someone has said I have mentioned it. I just don't remember it, so I don't know if you guys remember it. But how do we type cosecant in our calculator? Because we don't have a secant, cosecant, or a cotan anywhere on this calculator, okay? The mistake students make is they think they use the second button. They think of like that -1 as like a flip. It's not what that is. Remember, the inverse button gets us the angle. We only use the second inverse to find an angle. How do we put cosecant in? Do you guys remember? Good. 1 divided by sine. Yeah. Remember, they're flips of each other. The friends. Sine has a friend named cosecant. Every S needs a C. Cosine has a friend named secant. Every C needs an S. And tan and cotan go together. So if you flip one, you get the other. So I can take cosecant and do 1 divided by sine. Did I talk about that? Do you think? I don't remember. I really don't remember ever talking about that. But I'm glad I did. Yay me. 1.75 x. And let's graph. Oh, let me change my window. Oh, actually, I'm not going to change my window so you can see it first real quick because it's kind of nice to remember. Okay, there's my sine graph. And then cosecant is crazy looking graph. Remember, everywhere you had an x-intercept, you made an asymptote. And then at your mins and maxes, you made those little parabola looking things. You can see what it looks like there. But that's crazy. It's so hard to tell where 0 to pi is. So I'm going to go ahead and change my window to 0 and pi. Look at my graph again. And once you see it, we're really zoomed in. There's a part of your sine curve, and there's one of those parabola looking things, and then you're going to see a portion of another one. I think you guys would agree with me that there's 2 intersection points, so that at least gets rid of these 2, right? And then we're going to use that intersection button under calc. So second calc, go down to 5, and it decides it's going to put it somewhere. So it's just to the left of that intersection. So I'll start there. Why would I move already? Enter. And remember with intersection, it jumps to the other graph. Just let it do that. If I hit enter there, I'm going to hit enter here. Guess, yes please. And then we get an x value of 1.716. And that one is not over here. So you can go find the other intersection, but it is this. Okay? We will work on the FRQs Monday and Tuesday.